Here we have a SAT math problem. Okay, let's go to the question. Here we have a system of equations. This is x square plus 2y square negative 2x negative 2y equals to 7, y equals to k. In the system of equations above, k is a constant. For which of the following values of k does the system of equations have exactly two real solutions? Okay, when I consider the given system over here, so the first equation is almost in the general form of equation in circle, but here we have the constant on the right side. So if I make the right side 0, then we'll get the equation for circle in general form. For that, we have to subtract 7 from both sides of this equation. Then I'm getting x square positive y square negative 2x negative 2y negative 7 equals to 0. I subtracted 7 from both sides of this equation. Now I got the equation for circle in general form. So the second one is a linear equation, and you'll be getting an horizontal line for this one, y equals to k. Okay, now what I'm going to do is I'm going to find the center and radius of the circle over here. Once I get the center and radius, I'll be able to sketch the graph of this circle, and also I can sketch the graph of this line y equals to k, and I can find the value of the constant k for which the given system has exactly two real solutions. Okay, how do you have to find the center and radius of this circle? For that, we have to consider the equation for circle in general form, that is x square positive y square positive 2gx positive 2fy positive c equals to 0. Okay, comparing this and this, what value do we have for 2g? Actually, 2g is the coefficient of x. In our equation, the coefficient of x is negative 2. Then I'm getting 2g equals to negative 2. And 2f is the coefficient of y. Here the coefficient of y is negative 2. Then we get 2f equals to negative 2. And c is a constant. Here the constant is negative 7. Then we get c equals to negative 7. Okay, now let me divide both sides by 2 to get the value of g over here. Then 2 will cancel. G equals to negative 2 divided by 2 is negative 1. And to get the value of f, we have to divide both sides by 2. Then this 2 will cancel. Then I'm getting f equals to negative 1. Okay, now let me multiply both sides of this equation by negative 1. When I multiply this g by negative 1, I am getting negative g. That is negative 1 times g is negative g. When I multiply this negative 1 by negative 1, I'll be getting positive 1. And also let me multiply both sides of this equation by negative 1, then I'm getting negative f equals to positive 1. So here you have a question. Why do I have to multiply both sides of this equation and this one by negative 1? Because I want to get the value of negative g and the value of negative f. Because when the equation of the circle is given in general form in this format, so the center of the circle, so the formula to get the center of the circle is a negative g comma negative f. So here we got the value of negative g, that is 1. We can plug in 1 for this negative g, and here we got the value of negative f, that is 1. We can plug in 1 for negative f. So for this purpose only, I just multiply both sides of this equation and this equation by negative 1. So that is to get the values of negative g and negative f. Okay, now I got the center of the circle. Okay, now what I'm going to do is I'm going to find the radius of the circle. The formula to get radius of the circle when the equation is given in general form, that is square root of g square positive f square negative c. So then r equals to, already we know the value of g, that is negative 1. We can take negative 1 square. The value of f is negative 1, then negative 1 square. And here we have negative sign in the formula, and the value of c is negative 7. Let me write it over here. Then I'm getting r equals to square root of negative 1, the whole square is just 1. So here negative 1, the whole square is 1. And negative times 9 will become positive 7. Then we get r equals to square root of 9. Then I'm getting r equals to 3. Okay, now I got the center of the circle, that is 1, 1, and radius of the circle, that is 3. Okay, now let me sketch the graph of the given circle. Just a moment. So here we have xy plane. Let me mark the vertical axis y over here and horizontal axis x over here. Let me take over the value 1 over here, and 1 over here, 2, 3, and here we have 4, and here we have negative 1, negative 2, negative 3, negative 4. Okay, so the center of the circle is what, actually 1, 1. Let me take, so here we have the center of the circle 1, 1. Let me mark it. And the radius of the circle is 3. Since the radius of the circle is 3, let me take the vertical length of 3 units from the center 1, 1. So it's above the center 1, 2, 3. So then we'll have a point over here on the circle. Let me take the vertical length of the same 3 units, the radius, below the center. Then we get 1, 2, 3. So it's over here. So now we have to draw a circle with center 1, 1 through the points I have marked over here and here. Let me draw it, just a moment. 1 second. Okay, I just roughly sketch a circle. Okay, I've drawn the circle. Okay, now let me sketch the graph of the horizontal line now. That is y equals to k. But our aim is to find the value of k. Only if I know the value of k over here, I'll be able to sketch the graph of this horizontal line. So for that, we can use the values we have in the answer choices. Okay, so what's the value we have for k in answer choice A? That is 6. Then we'll be getting y equals to 6 when I plug in 6 for k. So y equals to 6 means like we have to draw an horizontal line through the value 6 on the y-axis. So here already we have 4 and we can take 5 and let's extend the y-axis and we'll have 6 over here. Then when I sketch the graph of the horizontal line y equals to 6, it's over here. And now this line, this horizontal line y equals to 6 does not intersect the circle. So the circle and the horizontal line does not intersect. So in that case, for the given system, there is no solution. So only if they intersect, we'll be able to get we'll be able to find how many solutions do we have. If the line and the circle intersect at one point, we can say there is a one solution for the given system. In case if the line and the circle intersect at 2 points, we can say there are two solutions. But when I consider the value 6 for k, I am getting a horizontal line through the value 6 on y-axis. In that case, a line and circle do not intersect. So no solution. So we can reject answer choice A because we have to get the value of k for which the system must have two real solutions. Okay, now let me take k is equal to 5. K is equal to 5 means we have to plug in k is equal to 5 over here. In that case, I'm getting y is equal to 5. That is, we have to draw an horizontal line through the value 5 on y-axis. When I draw an horizontal line through the value 5 on y-axis, again, the line does not intersect with the circle. So when k is equal to 5, the two graphs do not intersect. So there is no solution. So what we can do is we can reject answer choice B as well. Now let me choose k is equal to 4. When k is equal to 4, then this equation will become y is equal to 4. That is, we have to draw an horizontal line through the value 4 on y-axis. When I do so, let me do it. Okay, so the line and circle intersects at one point. Since the line and circle intersect at one point, there is only one solution for the given system, but we need to get the value of k for which the given system has exactly two real solutions. So we can reject the third answer choice 4 as well. Let me go to answer choice D. That is, we have k is equal to 3. In that case, this equation become y is equal to 3. Now let me draw an horizontal line through the value 3 on y-axis. Let me do it. Okay, when I draw an horizontal line through the value 3 on y-axis, the line intersects a circle in 2 points. So clearly, the given system has two real solutions when k is equal to 3. The correct answer choice for this question is D, k equals to 3.